We have seen how the histogram of the sample values traces the PDF. There is, however, a small adjustment to be made. The PDF and the histogram are plotted at different scales. In particular, the PDF is normalized in such a way that the area underneath the curve is equal to 1. Let's multiply the height of the bars of the histogram by a constant so that the area of the histogram is also 1. The function graphical comparison PDF is used to compare the histogram and the model PDF. The syntax is the following. It takes as arguments x, which is the vector that contains the sample, model PDF, which is a handle to the function that gives you the PDF to which you're comparing the sample histogram, a parameter whose value is either 1 if we scale the histogram or 0 if we scale the PDF, and then optionally you can also specify the range for the plot. First, we specify the default values. Then we take the sample and make it a column vector. M, given in this line of code, is the size of the sample. Here we're preparing for the plot of the PDF. We're going to plot 1,000 points, and for that we're going to generate equally spaced values between xmin and xmax in the x-axis. Then we'll just evaluate the model PDF at those values. We now calculate the area of the histogram. This is the line of code where we specify the number of bins of the histogram. A good rule of thumb is to use the square root of m or 40, whichever is smaller from those two numbers. This is the width of the histogram. That is the average height of the bars in the histogram. And finally, the area of the histogram is the width times the average height. The rest of the code is just devoted to plots. First, we calculate how high the bars are and where they are centered. Then we plot a bar diagram scaling the height of the bars by the area of the histogram. Finally, we plot the PDF and add labels to the plot. In this demo, we'll illustrate the use of graphical comparison PDF. We'll generate a sample of 1,000 values of log normal data and then compare their histogram to the model PDF. The parameters of the model PDF will be estimated from the sample itself. Since log normal random numbers are such that the logarithm follows a normal distribution, we can estimate the mu parameter by taking the mean of the log of the sample values. For the sigma parameter, we can take the standard deviation. This parameter here indicates that we're going to use m to normalize in the standard deviation. The reason for this is that these are the maximum likelihood estimates. Finally, we're going to compare the histogram with the model PDF. The handle to the model PDF is given here, and in this figure we're going to compare the sample S and the model PDF. And this is the comparison.